Hello, and welcome to my talk, Cutting Cloud Cost, Tackling Over-Provisioning with kube-prometheus-stack. My name is Michael Gutierrez. I am the Senior Manager of the Cloud Platform at JSR. A little bit about myself. I spent 6 years at AWS as a systems engineer, and I currently manage the Cloud Platform at JSR. We operate 45 AWS accounts and approximately 200 EC2 instances. I am leading a project to reduce our operational expense while maintaining high reliability. So first, what problem are we trying to solve? So I was trying to solve the problem of over-provisioning of our EC2 instances in our AWS environment. So what is over-provisioning? Over-provisioning is when your servers have too much resources and they're not being used, and therefore you are wasting money. Why is this so common? There's many reasons. One is default sizing. You have a new engineer and he is spinning up a resource and he will just pick the default size, which is often too large. There's also risk aversion. So people choose large instances because they want, to never have to worry about CPU or RAM being a bottleneck. Same thing with just-in-case provisioning. So just in case, our workload increases, just in case, we go viral, let's use too many resources. And then insufficient expertise. So if you don't know what you're looking at when you're spinning up a new EC2 instance, it's easy to choose the wrong option. So our hypothesis was that if we can prove an instance is underutilized, we can confidently downsize it without reliability hits. So a desired outcome was to spend less money while having the same performance. I really wanted to do this using data and observability and not just guessing, because again, we are trying to maintain the same reliability while just lowering the cost. So if we could actually prove that these instances were underutilized, we could confidently downsize them. So what did we choose to do? So we chose to monitor our EC2 instances using the famous kube-prometheus-stack. So what is this? It is a famous stack involving Prometheus, Alertmanager, Grafana, and Node Exporter. You can see a diagram of how it works. So why we chose this was it's open source, which is always a big win. And we already used it to monitor our Kubernetes clusters. So we were already paying for the provisioning of it and the maintenance, and we already knew how to use it. So what we did is we extended it to our EC2 instances using an agent that we installed on each EC2 called Node Exporter. So Node Exporter just looks at your common metrics and exports them back to Prometheus. And then we use Grafana to visualize that, and then Alertmanager to alert us when there's issues. You can configure Alertmanager to notify almost anything. We chose to use Slack because it's what our team uses all day, every day. So what metrics did we choose to monitor? So to find over-provisioning, we chose to monitor the CPU and the random access memory. So initially, we chose targets of at least 40% used once per month. So at least once per month, we need to see our CPU and RAM exceeding 40%. And then our target was 70% of all instances should meet these thresholds. this is this was kind of lower, but we wanted to start with something that was attainable. And then, as we go and as we progress, we will give smaller tolerance. We will, up the CPU so that we want to use at least, 60% of it, and then we'll increase the target as we see fit. But when we first implemented this, we wanted to make sure that we could have attainable results. So how do we implement this? As I mentioned before, we used the kube-prometheus Grafana stack. So we deployed Node Exporter on EC2 instances using Systems Manager. Systems Manager is an automation within AWS to automatically push software to EC2 instances. And we collected these metrics into Prometheus, and we built Grafana dashboards and alerts. So once a week, we get a summary of the alerts for instances that have not hit 40% of the CPU, and we get an alert for instances that have not hit 40% of the RAM utilization. Here's an example dashboard. So this is an example dashboard showing our random access memory. So you can see the count of the EC2 instances. This is just an example, but you can see the ones that have met this threshold, and you can see the ones that have not. And in the top right, we can look at different time periods. So this allows us to see, over months, quarters, years, days, whatever granularity we want to choose. We have the same dashboard, but for the CPU as well. Here is an example alert. So this platform team is in the Slack channel, and we get alerts once a week for CPU resources that are not all utilized well, and for RAM resources that are not utilized well. So these alerts are in our face, they're in our Slack, and we can go in and we can action these. So for instance, we may go into Grafana and we'll take a look, and we'll look at a longer time period, and we'll say, oh, yeah, this server didn't reach its utilization target this week, but it did over this month, or it did over this quarter. And then we will make intelligent decisions based off of that. If we go in there and we find, oh yes, this EC2 instance is not utilized well, then we will go through a process with the owner of the virtual machine, and we will actually help them to provision the right amount of resources for the workload. And this is only possible because we have the data that shows us, over time, how much did this EC2 instance use. So the results of running this, we ran this process for half of a year, and we ended up downsizing 20% of our EC2 instances and saving 10% on our AWS compute spend. Not only did we save 10%, but as I mentioned earlier, we have that data now, so we can make data-driven decisions, and we can even use this data for other activities or other needs. We also increased the cross-team collaboration. So we're the platform team. We don't own every service. So if we saw a service, like let's say our Power BI implementation, that needed to be changed in the resources that it utilized, we would contact that team and work with them. And they would trust us, to make the right decisions because we had all of those data points that we could point at, and we could help them make the right choice. And 10% is a huge savings. We're very happy with that. So What's next? As I mentioned earlier, we want to set up more aggressive thresholds. So right now we are targeting 40% CPU and RAM utilization. I'd like to increase this. I'd like to get as close as we can without hurting our reliability. We are also monitoring our reliability, so we'll be able to make the right decision and make sure that we can still have enough gap while not hurting our reliability. We also are going to monitor more things. So right now, as we've said, we monitor CPU and RAM, but I want to monitor I/O. So like AWS has hard drive volumes that you can attach, and you can monitor how much IOPS you use, how much bandwidth you use, etc. And we can make intelligent decisions based off of that. Many times for workloads, people over-provision the IOPS on hard disks. And so we want to monitor that and be able to also have that data so that we can change those instances to save money in our storage cost. We also want to implement more automations. So right now, it's quite manual. We get a Slack message with a resource that is underutilized, and we go in and we tweak it. We edit it, in our infrastructure as code, and instead maybe we could get a Jira ticket. Maybe it could automatically be assigned to the product owner. We could, automatically suggest an instance that meets the usage pattern better. Right now, we just look at the instance types and we make the best decision manually. But if we have the metrics on how much CPU and how much RAM it uses, we could also totally automate the decision on what EC2 instance we should switch to. With that automation, we could even, automatically switch these EC2 instances if we get to the point where we trust our process and we trust our data enough to automate to that extent. So if this interests you, if you are looking at saving money, if you know or if you hypothesize that you have EC2 instances that are underutilized or over-provisioned, then you can try this in your own workplace. So the steps for this would be to deploy the kube-prometheus-stack. I know lots of people have this stack already deployed. You can add Node Exporter to your EC2 instances. You can set the thresholds and set up alerts, and then just start tracking your over-provisioning. And as you track, as you get that data, you can then start trimming your EC2 instances and lowering the compute that is assigned to them as you go along. And you can constantly improve your compute resources so that you use the resources that you have to the best of its abilities. And you will save money. I know lots of people already have the kube-prometheus stack, so this is a good way to put it to good use and start saving money as a platform team. As a platform team, we have many jobs, but I feel one of them is to save money, and this process can definitely help with that. So I hope you enjoyed my talk. My name is Michael Gutierrez, and you can add me on LinkedIn if you have any questions or you want guidance or just to talk about how platform engineering can be used at your company. I would love to connect and talk with you. Thank you so much. Bye-bye.